Hey y'all, let's take a look at a lot of stuff today, so buckle up and get ready. So a couple of things you just want to make sure you understand. The idea of a number, that's an idea. Like if somebody tells you, oh, there are 3 wolverines clawing at your door. Well, you can visualize these, right? You don't need anybody to show you how many 3 wolverines, right? Okay, you can visualize 3 wolverines, okay? So somebody says, oh, there are 3 gluten and dairy-laden pizzas waiting for you to eat. You can visualize that right away. Okay, that's the idea. A number is an idea. The numeral would be this. That's the shape you look at and go, oh yeah, I know what that means, okay? And that's a Hindu-Arabic system that we derived that from. And the decimal system, we use that, the 10-digit system. What digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 digits. And, you know, decimals and saying things like that. When you write a number like this, you understand that with the decimal, that's 3, and then 0.7 means 7 out of 10. So, or 3 and 7 tenths. If you said 3.75, that would be 3 and 75 hundredths, and we've gotten used to using those numbers, and we do it automatically. It's almost like reading using phonics, okay? All right, a couple of things just to make sure you know the difference between the natural numbers, defined as natural numbers, are the ones you naturally use to count. So that's 1, 2, 3, and so on, all right? Real numbers are really any number on a number line. Any number out there that is on a number line. That's all we deal with mostly this year, in fact, all of this year. If you do Algebra 2, we'll deal with imaginary numbers, which are quite interesting and they're useful too as well. But we're dealing with real numbers. Anything you can stick on a number line anywhere, that's a real number, okay? The number line itself, you've seen these, right? That's a number line. You know, there's an origin at a 0. Everything over here is positive. Everything over here is negative. So in other words, if you wanted to do these integers at -1, and then we've got 2, and then -2, and it just keeps going on forever. And there is every number in the entire world between 0 and 1, and between 1 and 2. So there's an infinite number of numbers between those, okay? Opposites means, you know, a one number on the one side of the number line is exactly the same distance from 0 as the other one. So you can add those two together, and the answer is 0. Okay, we'll do more of that later. How to tell if a number is greater than another number? Well, let's say you had a number line. And I just said, there's the number A, and there's the number C, okay? Which one of those numbers is greater? And the answer is, it's C, because C is to the right of A. We don't care where it is on the number line. All we know is the thing is to the right of A. That means it's greater than A. C is greater than A in this case. Okay. All right, let's go back to some probably oldies for you here, I hope. And all these arithmetic things that we're going to do are important, because if you know how to do arithmetic, I'm talking about multiplying and adding fractions, dividing fractions, just, you know, finding common denominators and all that kind of thing. Well, once you know how to do what's on the screen there, then you do exactly the same thing when we eventually get to X's and A's and Y's and Z's and all that kind of thing. So you follow the same exact method. It's arithmetic, it works, it's going to work for X's and Y's too. In fact, that's kind of what algebra is. Just saying that it'll work for anything and just following through with it. So anyway, you tell me the method on multiplying fractions. What do you do? Numerators first, right? 5 times 7, 35. Don't try to cross anything like that. You're just multiplying. You're just going straight across there. Now, if you can cancel stuff first. So you have a smaller fractions to multiply. If you don't, you can just multiply and get a bigger number and then reduce it at the end. It doesn't matter which order. I would just do it at first if I could. 9 times 8 is 72, and that is it. We stop right there. Can't reduce that. All right? Divided by 7/5 divided by 11/14, that's the same thing as 7/5 times, you tell me, 14 over 11, right? Okay, all right. So you do exactly the same thing. You multiply across, you get your number. We won't even bother to do that. The key is when you divide a fraction, that's the same thing as multiplying. Sometimes I'll use a dot here instead of an X. We'll eventually stop using X's to multiply because they get confused with actual variable X. Okay, all right, if we have something like this, an easier way to do this, rather than multiply the entire thing without thinking, is to do what? Cancel, right? Okay, we're going to cancel this. All right, so you can look at 64 and 8 and go, okay, well 8 goes into 64 8 times, and then 8 just goes into 8 one time. There's there's nothing else we can cancel. So you just go straight across and go 7 times 8 is 56, and 1 times 9 is 9. Okay. Now if you want to go ahead and make this a mixed number, you can. You can go 6 and then 2 9s. That's okay. Either one of these is fine. Don't worry and think that, I mean, in algebra, eventually we're going to be going to all improper fractions, so it makes it easier to check our answers. Okay, what if it's something kind of convoluted looking like that? What do we got to do? I mean, you could sit there and do this all the way, you know, all the way across the top, all the way across the bottom, and then reduce until the cows come home. Okay, I wouldn't do that if I were you. I'd cancel. Okay. Easiest thing, of course, here is going to be 11 and 11, right? That's a 1 and a 1. Don't even need to write that really, but we can. Now you could do 4 and 28, like that's 1 and 7. Or you could do 4 and 6, 2 goes into both of those. Or you could do 21 and 28, 7 goes in both of those. The thing is, it doesn't matter which one you do first. If you have more to go, just keep doing it until you stop. You'll get the same answer as the person next to you, as long as the person next to you is doing it right. Okay. All right, let's just do 7s. 7 goes into 21 3 times. 7 goes into 28 4 times. Okay, well look at this. We got a 4 and a 4, right? Doink, gone. But look, we got a 3 and a 6 as well. So it's going to be 1 there, and that's going to be 2 there. Wow, the entire thing. We have 1 times 1, that's just 1. Then 1 times 2, no, that's it. So the whole thing's 1/2. That's all there is to it. Okay, how about this one? All right, take a minute and pause it and copy if you need to. Okay. One thing you want to make sure you don't do on these is go, oh, 2 times 5 is 10, and then 3/4 times 5/12 is this. I'm going to add. No, don't do that. Okay. You can probably figure out a rough answer about what this is going to be. This is almost 3, so we call it like 3, and then 3 times 5-ish. It's about 15, 16, or 17, something like that. So that's going to be our approximate answer. But let's go ahead and take both of these and make them into improper fractions, and then do the multiplication. So 4 times 2 is 8 plus 3 is 11, so 11/4 times, and then 12 times 5 is 60 plus 5 is 65. So 65 over 12, all right? Well, I don't see any way I can, you know, reduce this thing. So 11 times 65, excuse me, will actually be 715. You can do the, you know, the long multiplication over here to the right. Then 4 times 12 is 48, okay? So that's as far as we can go on that one. Okay, it doesn't reduce anymore. Okay, how about this one? Same exact kind of problem, right? Except we're dividing, which means we're going to do what to the second fraction? Flip it and multiply. Yep, okay. I'm assuming you said flip it and multiply. If you said stick it in a cheese grater, that's wrong. You're not going to stick it in a cheese grater. Okay. 3 times 10 is 30, plus 2, 32. That's the worst 3 I've written, so I'll do it again. 32 over 3. Okay, divided by, yeah, we'll get to that in a second. So 6 times 3 is 18. 18 plus 5 is 23. So we have 23 over 6. That's what we're dividing by. Since we're going to multiply, that means we're going to multiply by 6 over 23. Yep, flip it. Okay. And I would look at this and go, okay, 6 and 3, that's just going to be a 1, and that'll be a 2. Okay, so 32 times 2 is 64. 1 times 23 is, let me check this. Three, and 1 times 2. Siri, what is 2 times 1?
It's 2.
Okay, I figured out what 2 times 1 is. It's 2. So 64 divided by 23. There we go. Okay. I got it. Okay. All right. Well, this is the same kind of thing. Doesn't matter if it's a fraction or this means to divide. So it doesn't have a division symbol like this, but that's what we're doing. Okay. So you can even kind of predict what an answer would be. A little more than 5 divided by almost 2. That's going to be like, 2.5, something like that, maybe almost 3. Okay. Well, let's write this part new. So 4 times 5 is 20 plus 1, 21/4. And we'll divide this by, and let's go ahead and put divide. Same thing. 1 and 9 tenths. 10 times 1 is 10 plus 9 is 19. 19 tenths. So that means 21 over 4 times 10 over 19. And we can do this and this. We can knock that down by 2's. So 10 divided by 2 is 5. And 4 divided by 2 is 2. So 21 times 5, that's across, it's 105. And 2 times 19 is 38. And there you go. And don't worry that these are bigger numbers like 100 and 72 and 715 and 29. Who cares? Just write them out there and do it. Knock them out, okay? Okay, let's look at a couple of symbols. This is a true equation. The equals, we know what that means. It's the same thing as, so that means this is not equal, right? 5 plus 2 is not equal to 11, all right? Couple of operations. You don't get too hung up on these definitions, and you don't have to make any long, big, giant thing, okay? And let me tell you something right now you need to know. In your book, go ahead and turn with me to page 515, and you can pause it if you need to. 515 is a glossary. A glossary is basically a special dictionary for whatever book you're using, okay? So the glossary beginning on page 515 is, talks about all the different math terms that we go through, okay? Something else you need to know is that farther back in the book, and that starts on page 557, that's an index. So in case you forget to write notes or something and you're looking for a certain thing, you can look up the term in the index as well. Okay, all right. Well, a couple of things, let's just go this very quickly. An add-in, if it's 7 plus 3 equals 73, as we all know it is. This is the add-end right there, and this is another add-end, and that is the sum. Okay, that's not 73, it's 37. There we go, okay. The minuend and the subtrahend. Let's say you have 8 minus 5 equals 85, okay? There's the minuend. There's the subtrahend. Sub is Latin for under. And there's the difference. The answer, the word difference means the answer to a subtraction problem, okay? And now let's say you have 12 times 3, which equals, of course, 12d3, or 123, no. That's a factor, the answer is the product, the answer to a multiplication, okay? Dividend, divisor, and all those, these are all parts of division problems, 3 into 12. The answer is 4. The quotient is an answer to a division problem. Okay, so make sure you know that. All right, well, let's look at a few things. We're going to be messing with decimal numbers. We're going to add these two. And what's the secret on adding decimal numbers? You line up the decimals, okay? If there isn't anything there, you can stick a 0 if you want to kind of remind yourself that that's a kind of a placeholder. So let's do it. We have 7.0083, and we're going to add 0.05. Okay, let's just do it. 0.05, 8, 9, and 4, okay? And then you're just going to add straight down, of course, each time, all right? I won't bother to do that. You can do that. But you'll end up with a number. You'll carry the decimal down and then end up with your sum using those two numbers, all right? Subtract 0.05894 from that. Okay, well, you remember how to do these, 7.0083. And we're going to subtract this. We're going to do the exact same thing, 0, 5, 8, 9, 4. Now, you notice this is missing right here. So if something's missing here, you're going to go ahead and stick a 0 in there, all right? And we know how to subtract. We'll borrow here from here. That's a 2, and then that's going to be a 10, and the 4 is 6, and then we borrow again. We keep borrowing and so on. Okay. All right, good enough. All right, we're multiplying 8.06 by 0.073. I'll show you a trick on this that you might not have known before. When I was your age, I spent all this awful time doing all this kind of stuff. 8.06, and I do, 72,000 times 0.00094, excuse me, and all this jazz. What a mess. Writing all these zeros and decimals, don't do that, okay? 8.06 times 0.073, it looks like this, right? 0.073. And then you got, the decimals and this and that. Oh, man, okay. The trick is to remember, the answer to this problem is going to have 1, 2, 3, 4, 5 numbers behind the decimal. So in other words, the last 5 numbers of your answer are going to be numbers behind a decimal. If that is true, then forget all this 0.0, all this jazz. All you need to do is just do 806 times 73. Forget this stuff right now. All right? You do the math. Okay, 806 times 3, 6 times 3 is 18. 3 times 8 is 24. Okay, done. 7 times 6 is 42. 7 times 8 is 56. Okay, so we have an 8, a 3, an 8, another 8, and a 5. Okay, well, we have, again, 5 numbers behind the decimal and the answer. So the decimal just goes right there. And there's all 5 numbers right behind it. Okay, that's all you can need to do. Make it this way. Make it a lot simpler. Don't mess with all it. Make it as easy as you can. Then add the decimals later. Okay. All right. Divide this by 0.05. Okay. Well, this is a mess. So, and 4.072. Remember how to do these? Okay. You only want to divide what's called integers. So you're going to move this thing over twice to make yourself, a 5 here. All right. Then if you move that over twice, which means you've multiplied by 100, then you need to move this over twice as well, which means you've multiplied that by 100. And 407.2. And when you're dividing, you're going to carry that decimal up there. Okay? So 5 into 40 is 8. And that's perfectly, goes perfectly. So you're just going to carry your 7. So 5 into 7 is 1. 1 times 5 is 5. That's a 2, 22. 5 into 22 is 4. 4 times 5 is 20. And 2, and then you're going to carry down a 0 because you can always add a 0 there. So I just added a 0 to the wrong one. Okay, it's that one. Then there you go, and that goes perfectly, so you can stop right there. Okay. Okay. All right. Find the 12th irrational root of 0.05894. Now this is going to take calculus, square roots, imaginary numbers, and all kinds of things. So make sure you know. I'm assuming you know about imaginary roots, calculus, basic calculus. Operations, imaginary numbers, and okay, let's just skip it then, forget it. All right. Okay, last thing we're doing in this chapter is called unit multipliers. I strongly recommend that you take really good notes on these because this is really a cool thing that really works and it's very handy. You can convert things all over the place, okay? And you can do it on paper. And it's very useful. I mean, if you're walking 3 miles an hour, you can calculate how many feet per second you're actually going, and you can all kinds of neat stuff like that. Anyway, okay, you tell me the answer to that. What happens when you multiply a number by a fraction that's equal to 1? In other words, let's say you have a number 13. Okay, now I multiply this by a fraction that equals 1. Okay, what's the answer to that? What's 13 times 7 over 7? The answer is 13, right? Because 7 divided by 7 is 1. 13 times 1 is 13. Now, it might look different. 13 times 7 is 91. 1 times 7 is 7. And that looks different, but it's still 13 because we've multiplied by 1. You could take a jillion or a quillion or twiddly-2 or overly 8 or whatever number you can think of and multiply by 1, and it's going to be exactly the same number. Okay? If 2.684 times 29 over 29. Okay, sorry, the answer is still 2.684 because you multiplied by 1. Okay, if you multiply, on the other hand, by something, a unit multiplier that's equal to 1, I mean, you haven't changed anything. It's still going to be the same thing. It might look different. Okay, in other words, let's say you had 300 and you multiplied it by 1 yard divided by 3 feet. Well, what is 1 yard divided by 3 feet? It's 1, right? I mean, a yard is the same thing as 3 feet. If it's the same thing, you're dividing by yourself, the answer is 1. So 300 times 1 is 300. So you haven't changed anything. That's the trick we're going to do in changing units. So we're going to use unit multipliers, okay? We already did this one. What's the value of 3 feet divided by a yard? 1. What's the value of 12 inches divided by 1 foot? 1, right? It's equal to each other, so it's 1. Okay, we're going to use unit multipliers now, so definitely copy these steps down. I've got these really nice and streamlined for you. And again, make sure you're doing this with your notes, okay? You should have this for your notebook, like chapter 4, there it is. It's at the top right of your screen, or your page. So make sure your stuff looks like this, okay? This is how we convert units by using unit multipliers. So here we go. Number one, and of course, pause this if you need to copy. Number one is write what you're given as a fraction over 1. And I'll show you how to do all this. Write what you're given as a fraction over 1. Number two, don't forget, you can pause this. Number two is write a new fraction with this unit here that you used to start off with on the bottom, all right? Number three, multiply to cancel out the units. In other words, you're gonna have a fraction with this unit. Let's say it's feet on the top. You're gonna you have a new fraction with feet on the bottom of the new fraction, multiply it. So you go cross out feet, they go away. Okay, let's try it. All right, use a unit multiplier to convert 72 feet to inches. Okay, warning, you do not want to come across this and go, oh, I already know there's 12 inches in a foot, there's 72 divided by 12, the answer is 6 feet, I don't need to learn this at all. Ugh. Okay, because one of these days, it's going to be convert 72 cubic miles to cubic centimeters. You ain't going to be able to do that in your head, I guarantee you. Okay, so learn the method. This is the method. Okay, so the first thing you do, look at this, is write what you are given as a fraction over 1. What are you given? You're given 72 feet. That's what you're given. All right, so we're going to write, the first thing you need to do, here's a quick way of doing this too. Go ahead and just write what you're given, 72 feet. You're converting 72 feet, don't even think. Number one, just write 72 feet and abbreviate it if you want, as a fraction over 1, okay? Next thing you're gonna write is the new fraction with that unit on the bottom. So in other words, just go over here and write a fraction with feet on the bottom, okay? All right. So we're gonna multiply and cancel out these units, okay? So what we need to do is go, okay, we're trying to get this to inches, so we're gonna multiply now. And we go, well, 1 foot is equal to how many inches? It's equal to 12 inches. Because 12 inches divided by 1 foot is 1. We can multiply this by 1 all we want to, and it doesn't change the value of it. It just changes the way it looks, right? So look at this. Here's a quick question for you. Look down here. If you had a fraction like this, and it said 131 over 8 times 5 over 131, what's the easiest way you could tackle that fraction? You'd do what? You'd go, oh, cancel that out. Okay, that's exactly what you're going to do here. You're going to go feet and feet cancel out. Okay? All right, so look at this. 72 times 12 is what we have on top. And 1 times 1 is on the bottom. There's no need to write, divided by 1. You can just leave it. The unit we have left is inches. So you see, it wasn't right to go, oh, there's 12 inches, so it's going to be 6 feet, because that's not what we're doing. Okay, 72 times 12, if you do the arithmetic, is 864. So it's 864 inches. And again, one more time, you write what you're given. Don't even think, just write, I'm given this, write it as a fraction over 1. The next thing you do, don't even think, just whatever this unit is right here, write that unit on the bottom. And then figure out what kind of a conversion you need to do. You've done feet and yards and miles and feet and inches and feet and all that kind of stuff. So you know all that stuff. Then you go ahead and treat it just like a normal fraction. You multiply the tops, multiply the bottoms, do whatever arithmetic you need to do, boom, you're done. Okay, let's try another one. Convert 88 feet to miles. Okay, well again, don't think, write what you're given. What are you given? 88 feet, right? Okay, so there's 88 feet. Don't even think about it. You're given 88 feet, write it over 1, okay? Write another fraction. What goes on the bottom of this fraction? Feet, right? Because we're going to cancel it out, which we'll do in a second. Okay, you need to know, though, how many feet are in a mile. You know what the answer to that is? Okay, it's 5,280 feet equal 1 mile. Okay, now we're going to multiply it, right? Now what cancels? The feet cancel and the feet cancel. Okay, so we have 88 is on top. On the bottom we have 5,280 because they're both being multiplied by 1. And that's going to be miles. And if you want to, you can do the long division and figure out what that is, or just reduce the fraction, or however you want to handle it. But for our purposes, that's the method we're going to use, okay? All right, we're going to convert 58.75 inches to centimeters. Using your own multiplier. Convert 58.75 inches to centimeters, okay? All right, and all these, of course, pause this if you need to, okay? Here's what I'd do if I were you. Start doing this. Convert 58.75 inches to centimeters. If you want to kind of simplify that sentence that's in black, you can just go like this. You can go 58.75 inches to centimeters. You can, if you want to kind of simplify it for yourself, you can write it like that and kind of start that way. Okay, we know what we're going to start off with, right? You write what you are given. You're given 58.75 inches. So that's what you're going to write, 58.75 inches. Write it over fraction 1. Then immediately, what goes down here? Inches, right? Okay. Now, you might not know that 2.54 centimeters is equal to 1 inch. So let's write it now. 2.54 centimeters is equal to 1 inch. Now that we have an inch on top and an inch on the bottom, those cancel just like you would any other fraction, okay? Then all you're going to need to do is go 58.75 and then multiply that by 2.54, and the only unit you have left is centimeters, so the answer is centimeters, just like you want it to be, inches to centimeters. Boom, we won't bother to do that right now. Okay? All right, let's use this one. Use a meter multiplier, convert 37 meters to centimeters. Can you visualize a meter? Okay, that's a meter, a little longer than a yard. Convert that to centimeters. Well, same thing. A meter is 100 centimeters, so don't even think about it. You are given what? What's the first thing you're going to write with this one? 37 meters, right? 37 meters. If you want to, write it as a fraction over 1. The next thing, without even thinking, what is going to be down here? You know what's going to be down here. What is it? Meters, right? Okay. Well, they tell you a meter is 100 centimeters. So 1 meter is 100 centimeters, okay? What can we do with the meters now, the units? We're going to multiply, excuse me. And they cancel, right? Yoink, gone. Okay? So you have 37 times 100 is 3,700. The unit you have left is centimeters because it hasn't been crossed out, which is just what we want because we want to convert to centimeters. Boom, we're done. Okay. All right, a couple more, then we'll go on to the practice problems. Use 2 unit multipliers to convert 59 feet to centimeters. Okay, ooh, here we go. This will be interesting, okay? And this is exactly this. Now, and again, if you want to write down, I'm going to go 59 feet and convert it to centimeters. And that kind of, you know, shortens it for you, lets you focus on what you need to do. Okay. Well, what you need to write immediately, like that, is what? Without even thinking, what do you write? What are you given? 59 feet, right? So 59 feet. And you can write it as a fraction over 1. And immediately you write a fraction next to it, and what do you know is going to be on the bottom? Feet, right? Okay. Well, feet in centimeters, I don't know about that. Oh well. What do you know about feet? What does it convert to? Feet converts to inches, right, in this case. So we're going to multiply, and we'll say 1 foot is the same thing as 12 inches, right? Okay. Well, now we can cancel the feet. And we have inches. We're done. No, we're not. We want to convert to centimeters. Well, wait a minute. I remember something. Hang on a second. Look, 2.54 centimeters is 1 inch. Write that down and memorize it. So what we can do now is, if it worked this time, well, let's just do exactly the same thing, except for this time, what has to be on the bottom right there? What unit to cross out? We've already crossed out feet, right? Now we need to cross out inches. Gone. 1 inch is 2.54 centimeters, right? And now we can go inches also cross out. Okay, now we have 59 times 12 times 2.54, and that's going to be the centimeters, okay. And we won't bother to do the arithmetic right now. That's not the important part. Make sure you can do that. Okay? All right, one more. Use 2 unit multipliers to convert 6 miles to inches. Good grief. Can you imagine how many inches are in 6 miles? Crazy. Okay, let's look at it. First thing you do, without even thinking, what do you write? What are you given? 6 miles, right? Okay, 6 miles. That's what you're given. Put it over a 1 if you want. Make it easy for yourself. Immediately, what goes down here? Miles, right? Okay. Well, a mile is how many feet? At least we know that, right? Let's multiply. 5,280 feet. Okay, miles go away. Now we have feet. Oh, we don't want feet, we want inches. So we're going to have to do this thing again. What goes on the bottom this time? What goes here? Feet, right? We don't even worry about if you know the answer yet. Just put feet down. You know you got to cancel that out. Okay, so 1 foot is the same thing as 12 inches. So feet and feet cross out. Okay, now we have inches. That's what we want. And the actual arithmetic will be 6 times 5,280 times 12, whatever that is. It's 72 times 5. You can do the arithmetic if you want to, but that is a lot of inches, and the only unit that's left is inches, just like it is right there. Okay, so we're done with that. All right, let's give the practice set a whirl and see what we get. And go ahead and pause it, and then come back when you're finished with A. Okay, A is going to be 12 3/5. If you, there'll be 9 halves times 14 fifths, which reduces, and you can do the arithmetic there. It's 12 3/5. Okay, pause it and try B. Okay, B will be 2 4/11. 2 4/11. Don't forget you multiply the second fraction after it's inverted. Okay, pause it and try C. Okay, if you line up all the decimals, that is your answer, 760.939. Pause it and try D. All right, again, lining up the decimals, you'll get 724.74. Right, pause it and try E. Okay, you're going to know, you're going to have, in this problem, that doesn't look right. 47.05 times 6.42, that ain't right. 47.05, that's what I have, times 6.42, okay, that's not right. Well, let's do it together. So that's going to be 10 and 94, or 47.05 times 2. 4 times 5 is 20. 4 times 47 is 188. 6 times 5 is 30. 6 times 47 is 282. All right, so we have a 0, a 1, a 6, that'll be another 0, and that'll be 2 there. 2 plus 8 and 2, that'll be 12. That's a, and a 1 and a 3. Okay, so we have 1, 2, 3, 4, 1, 2, 3, 4, 302.0610. Of course, that's the same thing. Gotcha. Okay, all right. All right, pause it and try F. All right, the division problem, you're going to want to go ahead and turn the number you're dividing by into an integer, so you'll get 100.7 is your answer. All right, 2 more to go. Pause it and try G. We can do that together if you want to. In fact, let's go ahead and just do G together. All right, when you're finished, you can unpause it and look at what we're doing. Okay, 75 feet to centimeters. Okay, so don't think, just write 75 feet. There it is, fraction over 1. Times it by, I don't know what it's going to be, but I know there's going to be a feet at the bottom. Okay, well, we can go, okay, foot is 12 inches. Those cross out. We got inches now. We don't want them, we want centimeters, right? Okay, so we're going to go again and do exactly the same thing. And you know what's got to be on the bottom here. It has to be an inch, right? So inches over inches, boom, that's going to go away. And 1 inch is equal to 2.54 centimeters. Okay, so we have the unit we want, centimeters. Okay, 75 times 12 is 900. 900 times 2.54, let's just do this. We'll do it this way. Let's see here, 486, that'll be 2286. Okay, 900 times 2.54 is 2,286 centimeters. And there we go. Okay, all right. There is H. Let's try H. If you want to go ahead and pause it and try H, we can wait till you're done and then do it then. Okay, so we have 450 inches to miles. Good gravy. So we start with writing this. Don't think, just write what you're given over a fraction and start multiplying, okay? You know inches have to be at the bottom. There's your inch, all right? 12 inches in 1 foot. Inches go away. Now we have feet. We don't want feet. We want miles, okay? We're going to do the same thing again. We know we have to have feet on the bottom of this one, right? So we can cancel out. So feet go away. But how many feet are in a mile? Well, 1 mile is equal to 5,280 feet. Okay, so we have 450 on top. On the bottom, we have 12 times 5,280. And we have, that's how many miles there are. Now, if you want to do the arithmetic, that's fine. You know, I think sometimes in your book, they're actually going to just leave it like that. And you can do it if you need to. So anyway, okay, long lesson. Thanks for hanging in there. I will see you guys next time and have a great day.